Imagine a structure so massive it could envelop an entire star. Welcome to the astonishing world of Dyson spheres. This concept, as mind-boggling as it may sound, is the idea of a megastructure that completely encompasses a star, capturing most or all of its energy output. Picture this, an immensely vast shell or series of rings built around a star, siphoning off its energy to power who knows what incredible technologies. This isn't the stuff of science fiction, mind you. The idea was first proposed by the physicist Freeman Dyson back in 1960. He envisioned a civilization advanced enough to harness the full power of its star, a level of progress we can only dream about, but who knows what the future holds. And that, dear viewers, is the mind-boggling idea of a Dyson sphere. Now, how can we grasp the enormity of a Dyson sphere? It's like trying to imagine the depth of the ocean while standing on the beach. To get a grasp on this, let's compare it to some of the most massive human-made structures. Take the Great Wall of China, for instance. Constructed over 2 millennia ago, it stretches over 13,000 miles. Now that's impressive, isn't it? But if we were to build a Dyson sphere, the Great Wall would be akin to a grain of sand on a vast beach. Then we have the pyramids of Giza, these ancient marvels, constructed from over 2.5 million blocks of stone. Yet, if each block represented a star within our galaxy, we'd need to build over 100,000 more pyramids just to represent all the stars in the Milky Way. And remember, a Dyson sphere is designed to encompass an entire star. Let's go a step further and consider the International Space Station, our outpost in the low Earth orbit. This technological marvel took over a decade to assemble and required the cooperation of 15 nations. But to construct a Dyson sphere, we'd need to mobilize resources and manpower on a scale that dwarfs any global effort we've made so far. A Dyson sphere is not just a megastructure. It's a hyperstructure, the likes of which we've never seen before. It's a monument to a civilization's technological prowess, a testament to its ability to manipulate and harness the raw energy of a star. It's not just a construction project, it's a transformation of the cosmos. So when we talk about the Dyson sphere, we're not just talking about another Great Wall or another pyramid, we're not even talking about another space station, we're talking about an undertaking so massive, so ambitious that it surpasses anything we've ever conceived. So we see that the Dyson sphere truly is in a league of its own. The sheer scale of a Dyson sphere is only the beginning. Now let's delve into the staggering numbers behind it. To construct a Dyson sphere, we would need a mind-boggling amount of resources. Let's start with the most essential one, material. It's estimated that we would need around 300 quintillion tons of matter. That's a 3 followed by 20 zeros. To put it into perspective, our dear Earth weighs about 6 sextillion tons. So we would need the equivalent of 50,000 Earths just to gather the necessary material. Now on to the time it would take. If we were to employ every single person on Earth, having them work round the clock, it would still take us about 100 quintillion years to complete. That's longer than the age of the universe itself, which is a mere 13.8 billion years. But what about cost? Brace yourselves, because the price tag is simply astronomical. If we were to put a price on the required material alone, assuming a cost similar to that of steel, we would be looking at a figure in the region of $600 sextillion. That's a 6 with 23 zeros after it. To put that in context, the entire global economy is valued at approximately $100 trillion. So the cost of a Dyson sphere would be 6 billion times the current worth of our entire world. These numbers are, of course, purely theoretical and should be taken with a pinch of cosmic dust. They serve to illustrate just how grandiose the concept of a Dyson sphere truly is. It's not just about the size of the structure, but also the monumental effort, resources and time required to construct it. Just as the Dyson sphere dwarfs all other structures, so too do the numbers involved in its construction. The question then arises, can humanity ever build a Dyson sphere? Think about it, it's not just about the raw materials that would be required to construct something of this scale. We're talking about quantities of resources that would dwarf the combined output of every mine, quarry and drilling rig on Earth. But it's not just about the resources. It's also about the technology. We're not just talking about advanced materials and propulsion systems. We're talking about tech that doesn't even exist yet. And let's not forget the logistics. Imagine the coordination required to construct something on this scale. It would be like building 1 million Great Walls of China in space. But perhaps the biggest challenge of all is time. Even with the most optimistic assumptions, it would take centuries, if not millennia, to complete. While the Dyson sphere remains within the realm of science fiction for now, who knows what the future holds? So what does all this talk of Dyson spheres mean for us? Well, it's a testament to the boundless reach of our collective imagination, a symbol of the audaciousness of human ingenuity. This idea, conceived in the realm of science fiction, has sparked serious scientific discourse and debate. It's an awe-inspiring concept, a mammoth task that challenges our current understanding of technology and the universe itself. Dyson spheres, in their grandeur, represent more than just a potential solution for energy demands. They stand as a beacon of what we as a species can aspire to achieve. They encourage us to question, to innovate, and to dream beyond the confines of our planet. The discussion around Dyson spheres isn't just about their feasibility. It's about the spirit of exploration and the relentless pursuit of knowledge. Whether or not we ever build a Dyson sphere, the concept itself reminds us of the limitless potential of human innovation. And remember, keep exploring the cosmos with us. Don't forget to hit that subscribe button for more fascinating insights into the universe around us.